Well, here we go again. So far we covered how do we segment the network using a fixed number of, a fixed subnet mask. And we said we have two categories under that. Sometimes you'll be asked to subnet or segment a network having the number of networks that you need. Or sometimes they will tell you, well, we need to have a number of networks without specifying that number and tell you each network should be able to host or have a number of host devices, 12, 15, 16, a number. Now, with the second one, we said basically after you figure out how many bits you will need for the host portion, the remainder of the bits are going to be borrowed to the network portion, and those number of bits is going to tell you how many networks you can have. Let me just go and remind you about that. So in this area here, we found out if we want to have 12 hosts for each network we're going to create, we need to keep 4 bits for the host portion, and then since we have 8 bits here total for the host portion, then the remainder of the bits, which is the green 00, are going to be borrowed to the network portion. And since I have 4 bits, I know that I will have 16 different networks. And then after that we said, since we have 4 bits to borrow, then the second or the final prefix is going to be 28. So that's basically what we had so far, and this is what we covered. Now we're going to talk about the VLCM. Now let me just go back and show you a scenario here, and let's look at this PowerPoint. Each one of those switches you see at the top here represent the network. So I do have 1 network, 2 network, 3 network, 4 networks. Now each connection between 2 routers is a network by itself. So I do have 1, 2, 3, 4, and here I have 1, 2, 3. So the total number of networks here I have 7. Now since I do have 7 networks, you don't have to look at those numbers. I'm just going to choose a number that makes it a little bit easier. Since I need to have 7 networks, and I want you to pay attention to this, let's imagine the prefix was 24. 24, that's the prefix. And I want to create 7 networks out of that. Well, basically that means I need to borrow 3 bits. 3 bits because we said when you borrow 3 bits, then the number of networks you can create out of those 3 bits are 8, and since I need 7, so yes, that will be more than enough. But I want to ask you a question. Now let me just go ahead and do the calculation in the Word document. I'm going to erase it later. Just imagine, again, number of networks needed is 7. Let me just go down here. If the network IP address is, let's say, 192.168.75.0 and 24 prefix, that basically means we need to borrow 3 bits from the host portion to the network portion. Okay, so we're going to borrow 3 bits, and since we're going to have 3 bits, we will have 5 bits remain for the host portion. So previously we had 8, and we're going to take 3 of them, so we're going to have 5 bits. The new prefix is, since I'm borrowing 3, and I have already 24, so it's going to be 27. That's going to be the new prefix. Now, this is not what I'm worried about. The calculation basically can go ahead and do the calculation. But here's what I want you to do, and I want you to pay attention to. How many hosts I could have for each network in this case? Well, each network can host 2 to the power of 5 minus 2. Let's just fix this to the power of 5. Which basically means 2 to the power of 5, it's 32 minus 2, that's 30 hosts. So basically, what I'm saying here, based on the analysis that I just showed you here, each network will be able to host 30 different devices. Now, what I'm going to take you to the graph again here. What does that mean? Basically, this switch here could be connected to 30 devices, 30 devices, 30 devices, 30 devices. Those are the 4 networks. And the same thing is applied here. This network basically will reserve 30 IP addresses for host, 30 IP addresses for host, and 30 IP addresses for host. So each one of those 7 networks that you can see here in this slide here can host 30 different devices. Now, what I want you to pay attention here to this network here between this router and this router. This router network basically has only 2 ends. One end is at this router and the other end is this router. What does that mean? It basically means I will use 2 IP addresses in this network, and I'll be able to use another 2 IP addresses from another network IP address, and I'll be able to use only 2 IP addresses. What does that mean? As I said, each one of them can will reserve 30 IP addresses, but again, I'm just using 2 here, and I'm just using 2 here, and I'm using 2 here. What does that mean again? Basically, it means I'm going to be wasting 28 IP addresses here, another 28 IP addresses here, and another 28 IP addresses here. That is the problem of the previous method, which is what we call a fixed subnet mask. When you go fixed subnet mask, basically, each one of those networks will have the same number of IP addresses that's going to be available for that network to use. We can call them reserved IP addresses. So each one of those networks, the 7 networks that I have here, will be able, or will reserve 30 IP addresses. Now here, since I have a switch, I can use 30 devices with no problems. But the connection between those routers can only use 2 IP addresses, and this only can use 2 addresses. And that basically means I'm reserving 30, and I'm only using 2, so 28 is going to be lost here, 28 is going to be lost here, and 28 is going to be lost here. Now, we already said one of the biggest problems with IP addresses 4 is that the limitation that we have, not only it's limited, and now we're wasting some of these IP addresses. So for that reason, we do have what we call a VLCM. Now I'm going to jump into an example to explain how does it work, and let me just tell you something, it's not any different. Oh, actually it's a little bit different, to be specifically. It's a little bit different than this technique here that we have here. I'm going to show you how it works, and I'm going to make it a little bit easier because I don't want to go through a lot of calculations. But let me just mention here the fact that I was talking about here. So each, I wrote that thing. What if a network only needs 2 IPv4 addresses? That basically means 28 reserved IPv4 addresses will be wasted. Okay, so since that's the case, what is the solution? VLCM. Let's just emphasize that. VLCM. Okay, so let's say example. And this will be the end. After I'm done with this example, I'll be done with explaining what this chapter is all about. But here is what you have to do. Always remember, you will need to study very, very, very carefully about this chapter. Pay attention to this chapter. Read, finish all the labs and exercises about this chapter. This is extremely important. So let's go ahead and have this example. Let me just write a note here so I don't forget about something here. Okay, let's go back and start with the example itself. I'm going to come here and let's say use the following network IP to or segment network IP address okay, I'm just trying to remember the phrase here. Segment the following network IPv4 address. Let's just run it. 192, 168, 75, 0, 24. For the following networks. So let's go ahead and list those networks. So network number 1 let's go ahead. Network number 1 is going to host, let's say we do have 55 hosts. Network number 2 has 28 hosts. Network number 3 has, let's say, 9 hosts. So here we go. I want you to pay attention to here. Basically, I'm going to divide this network based on the number of hosts. But again, each network itself has a different number of hosts. So how do we do that? Well, basically what we do, we just repeat what we learned previously with the previous example. And we apply that to this network, which is the 55 hosts. I'm going to assume that all the networks, well, I don't have to assume that, but again, the first network will need 55 hosts. So let's go back and copy the network IP address. Here it is in binary, and let's put it here. And I want you to pay attention. I'm going to put them all now. Let's go back to the fact that I didn't do anything yet, so I'll just keep this portion to be green. Now, since I need 55 hosts, I need to understand how many bits do I need to borrow to be able to have 55 bits, 55 hosts. Well, again, remember, we use 2 to the power number of host bits minus 2 should be greater or equal to 55. And just to save you some time, this number is basically 6, because 2 to the power of 6, let me just fix this here. 2 to the power of 6, actually not 6, let's just use a calculator. Let's use scientific. So 2 to the power of, let's say, 7 equal 128. Well, that's not it then. It's 6. So 2 to the power of 6 equals 64 minus 2, and that is 62. What if 2 to the power of 5? Well, 2 to the power is 32, so it's not going to work. So I need 6 bits here to borrow. Sorry, not to borrow, to keep. 2 to the power of 6. I'm to keep 6 bits here for the host portion to be able to have 55. I'm going to have more than 55, just to tell you, but since I get 62, so that's basically the number that I'm looking for, because less than that I cannot. So what I'm going to do, I'm going to just highlight those 2 bits. So here we go. This is the first network IP address. Now what I'm going to do, I am going to take this as it is, and I am going to show what will be the network IP address for this case specifically. So it's going to be first network, is okay. So basically 192, 168, 75, and then 00, sorry, not 0, just 10, but the prefix is basically going to be, instead of 24, it's going to be 26. Why 26? Because I'm borrowing 2 bits. So that will be my first network IP address. Now, what will be the second network IP address? Well, this is not the second network IP address, but I'm just going to show you what's going to happen. From this network IP address, from those 2 bits, I can have 4 different network IP addresses. What I'm going to do, I'm going to take the second available network IP address and subnet it or segment it further for this purpose. So let's just take that. Let's have a look at this address. Let me just copy this. And I'm going to put it here. Now, here's what's going to happen. At this point, this is going to be changed to be 1. Why? Because 0 has already been used here. Now, what I'm going to do, I'm going to change this to be yellow, this segment. This is extremely important. Now, what I'm going to do, I'm going to apply the same concept that I applied here to those 6 IP addresses. Oh, sorry, 6 zeros that I have, the green ones. And I'm going to try to segment it further, and knowing that the number of hosts is 28. And remember here, I do have 6 bits here. So remember, we use the same rule. So we need 6 bits for the host portion. Okay, so let's go back here. Remember, this is basically the network portion, and I borrowed 2 bits, so the 00 is reserved and used for the first network IP address. Now moving on to the second network IP address, which is 28. And for the 28, the first thing I'm going to do, I'm going to use the second available network IP address, which is basically the same as the 1, except that I'm changing this 0 here to be 1. Now, this portion here, I'm going to segment it further. Keep going with that. So, I do have 5 or 6 bits. Now, the question is, how many bits do I need to be able to have... let me just put it in this area here. So, it's 2 to the power of 6 minus 2, that is greater or equal to 55. So let's go ahead and put this to the top, and that's it. Now let's go back here and do the same thing. Remember, the number this time is going to be 28. That's the number of bits that he's looking for. So let me copy this, put it here. So instead of 55 this time, it's going to be 32. Now, what will be the number to go for? Oh, sorry, not 32, 28. Okay, so I have 6. I cannot go with 6. I can go with, because 6 has already been used, I need to go further. I'm going to go with 5. Now, 2 to the power of 5 is 32. Minus 2 is 30. So 30 is acceptable. It's greater than 28. So 2 to the power of 5 minus 2 is basically greater or equal 28. I'll just fix this 5 here. Go to the power. And then we need we need 5 bits for the host portion. Now remember, I do have 6 bits here. So what does that mean? That basically this part, those 5 bits are going to be reserved for the, and this bit here is going to be converted to, well, it's not going to be converted, we're just going to change the color to be purple. So basically I'm borrowing extra bit to be able to have the new network. Now, what will be the second network IPv4 address? Well, let's just start and just take it easy. 192.168.75 dot. Well, let's look at this number here. If I want to change this to be decimal, what is that going to be? It's going to be 64. Now, remember this. Since this is 64, what will be the prefix for this case? Now remember, previously it was 26 when I added those zeros and 1 here to the 24. Now I'm adding another 1 to them. So what was 26 before is basically going to be 27 this time. And that's basically the second. Let me just type it here. Oh, why is it here? Okay, I see what's going on here. The second network IPv4 address is basically this number here. Okay, now let's keep going. What will be the third one? Well, now just remember here, I used the first one when I borrowed 2 bits for the 55 hosts. And then the second available network IP address is going to be basically the same 00, but instead of 00, the purple 00 here is going to be 01. I take this IP address, this network IP address as it is, and subnet it furthermore. So I ended up borrowing another bit from the host portion to the network portion. Now look what I'm going to do. This is very important. What I'm going to do, I'm going to take this, put it here, and I am going to change this 0 to be yellow. But just remember, since 0 is already been used here, I'm going to change it to 1. So this is the next available IP address for this network when I did the segmentation here. Now remember, I do have now 5 available bits for the host portion. Let me change this, make it a little bit smaller. I'll put 5 here, just to show you a little bit different example. Well, since I have 5 bits here, 5 hosts that I need, I'm going to copy the same thing here. Basically, the number of host bits minus 2 should be greater than 5. Now, if I choose to put 3 here, 2 to the power of 3 is 8. 8 minus 2 is 6. So that basically, yes, I can actually do that. I do basically need to have 3 bits for the host portion. Now look at this. I need those 3 bits. So what's going to happen to those 2 bits? Well, basically, they're going to be borrowed to the network portion. So I can come here, let's just highlight them with the color purple. So I'm going to keep those 3 bits here for the host portion, and 2 other bits are going to be added to the network portion, and they're going to be 0, 0. Now, all I have to do is to type the third network IPv4. Oh my god, I'm really, really tired. I've been talking for a really long time this morning. Is 192.168.75 dot. Let's look at this network IP address now. What do I put here? Well, this is 64, and this is 32, and I think that's 96. Let me just make sure that the calculation is correct. 64 plus 32, 96. Now, what will be the prefix for this case? Remember, previously I had 27, and now I'm adding another 2 to that. So basically, it's going to be what? 29. And that's basically how we do it. Now look at this. Look at all the calculation that I had to do here compared to all the calculation that I had to go here. Number one, there will be no wasted IP addresses. And the idea here, I'm adapting the technique that I used here with a fixed number of hosts. So instead of having each network to have 12 hosts, what I did basically, I started with the host that has the greatest number, with the network that has the greatest number of hosts, and then I subnetted the network based on that. So I got myself the first network IP address. Right after that, using the same network, the second available network IP address that I actually got this one from, and basically, which is basically this case here, 0, it was 0, 0 here, and now it's 0, 0, 0, 1. I repeat the same thing for this network IP address. Now this is a new case for segmenting, where I have a new network IP address, and I just have to go further and subnet it. So in this case, I had to I had to keep 5 bits for the host, and that basically led me to have an extra bit to be borrowed to the network portion. And as a result, I got this network IP address. Right after that, I had the third network IP address. So what I did, since this is 010, so I'm going to have 011 as the next available IP address. And since I have only 5 bits, so 5 hosts required, I needed only 3 bits for the host to be able to host those 5 devices. And as a result, I got this network IP address. Now what I want you to pay attention to here is how the prefix is changing as you keep going. And that's the reason why it's called VLSM, Variable Length Subnetting Mask. Every time you do segmenting, or subnetting, you're basically having a different network prefix. This will end the calculation part, and I'm going to happily upload this file. Hopefully it's going to help you guys understanding this concept. I'm going to go to the PowerPoint. The PowerPoint basically is not telling that much, and I highly recommend to go and check the videos available in the Net Academy. This is just basically explaining why do we actually need to have the VLCN. This graphic here, let me just zoom a little bit, just to show you the difference between variable and fixed. And you can see here, I have the 3 hosts here, and I can take one of the network availables host and divide it furthermore to get smaller networks. Let's go back here. The rest of this chapter, which is basically a structured design, if I want to summarize those 3 slides, this basically means whenever you want to actually build a network, it's highly recommended to have a table with all these IP addresses. This is very, very important. In this table, basically, you will tell what is the port IP addresses, what is the default gateways, what is subnet mask, if you have servers, if you have clients, all these kind of details, if you can put them on a piece of paper, well-organized piece of paper, that will make your job a lot easier. Never ever depend on your memorization for all these numbers, because believe me, you'll make a mistake. This will be the end of this chapter. Now, what I want you to do, basically, I want you to look at those videos. I want you to study the Word document, study the PowerPoint, go to the Net Academy, finish the requirements for this chapter. I will post and I will work on the next chapters. The IPv6 is a piece of cake. Don't worry about that. And then the part after the IC, let me see what goes next. Let me just get back here. The ICMP also, it's a piece of cake. So this is the most complicated part. Just remember, this Friday we'll have the first exam, and the second exam, and that exam is going to be about modules 4, 7, Ethernet. So I am going to take a break for now, go play some video games, and after that I will come back here to get some other job done. Well, have a good day and enjoy your last day of your spring break.